In this video, we are going to take a look at some trigonometric identities. So, we have our familiar right angle triangle over here, ABC, with angle B equal to 90 degree, and angle C is theta. So, angle C is theta. Now, suppose we start off with sine squared theta plus cos squared theta. So we know from our last video that sine theta is P by H. Now sine squared theta means sine theta the whole square. So this thing actually means sine theta the whole squared, and since sine theta is P by H, this will mean P by H the whole squared, which is P squared by H squared. So here sine squared theta will mean P squared by H squared. Similarly, cos squared theta means, since cos theta means B by H, so cos squared theta means B squared by H squared. Now this will reduce to P squared plus B squared by H squared. And we know from Pythagoras theorem that P squared plus B squared is equal to H squared. Hence this will be H squared by H squared, which is equal to 1. So from this we have our first identity, which states that sine squared theta plus cos squared theta is equal to 1. So that is our first identity. And from this we can derive sine squared theta is equal to 1 minus cos squared theta. Okay, if we take cos squared theta to the other side, we get this. So only sine theta will be equal to root of this 1 minus cos squared theta. Similarly, if we keep cos squared theta on the left hand side and we take sin squared theta to the right hand side, we will have cos squared theta is equal to 1 minus sine squared theta. So obviously, without the squared, cos theta will be equal to root of 1 minus sine squared theta. So from this basic identity, that is sine squared theta plus cos squared theta equal to 1, we can derive 4 other identities. Similarly, we have another 2 sets of such identities which we can derive from this triangle, just like we have derived this in this way. We are not going to explicitly derive those over here, that is left to you as an exercise. I am just going to write down those identities so that you get them in one place. So the next identity will be sec squared theta minus tan squared theta is equal to 1. So what can we derive from this? We can derive sec squared theta is equal to 1 plus tan squared theta and sec theta is equal to root of 1 plus tan squared theta right. Again, if we keep tan squared theta on the LHS and we take sec squared theta to the RHS, what we'll have is tan squared theta is equal to sec squared theta minus 1. Similarly, removing the square, we get tan theta is equal to root of sec squared theta minus 1. So from this basic identity over here, sec squared theta minus tan squared theta is equal to 1, we can derive the other 4 identities. We have one more set, and that also I'll be writing down over here for your reference, and that set is cosec squared theta minus cot squared theta is equal to 1. That is the basic one, and from this we can derive 4 more. So cosec squared theta will be equal to 1 plus cot squared theta so cosec theta will be root of 1 plus cot squared theta. Okay, and two more we have, that is if we keep the cot squared theta on the left hand side and we take the cosec squared theta to the right hand side, we will have cot squared theta equal to cosec squared theta minus 1, and if we want to remove this square from here, we will have cot theta equal to root of cosec squared theta minus 1. So the basic one in this set is this one, cosec squared theta minus cot squared theta is equal to 1, and we have 4 identities that have been derived from this. So these 15 identities are the basic identities so far as class 10 trigonometry is concerned. You have to go through them very well and you have to memorize them so that you can use them to do the proofs in trigonometry. So we'll come back again for another video of trigonometry. For now, this is it. Thank you.